Now a cripple wall is just like what you see right here. This is the foundation of the house. This is the wall, that's called a cripple wall, and then this right here is the floor that you walk around on. A good way to find out if you have cripple walls is if you have more than 2 or 3 steps leading into the front door, good chance you have one. Now here's a blown up view of a cripple wall. I'd like to point out this is the floor that you would walk around on. This right here is the cripple wall itself. This is what's called the mud sill, and then this here is the foundation. If the cripple wall collapses, the house will fall off its foundation. Here's a good example of a cripple wall collapse. This is the cripple wall itself. Here is the foundation, and this is the floor of the house right in here. And when it moved this way, the cripple wall was just too weak. And the purpose of a seismic retrofit is to make sure the cripple wall is so strong it does not collapse in an earthquake. Here's a good example of a cripple wall collapse. So this is the floor of the house now. And it used to be that you would go up into the stairs and then into the floor because it was elevated a few feet, and that was the cripple wall. And now the cripple wall has collapsed, and now the floor of the house is way down here on the ground. So the whole purpose of a cripple wall retrofit is to prevent that from happening. Here's a good example of how cripple walls collapse. This is the cripple wall itself. This here is the foundation, and then this here is the floor that you would walk around on. Now right here you can see where the ground has moved underneath the house. And when that happens, inertia causes the cripple wall to lean. And as the earthquake continues, then the inertia causes it to lean even more, and eventually you end up with complete collapse. Plywood is what prevents cripple walls from collapsing. So as you can see here, as the earthquake force tries to cause the cripple wall to collapse, we just put plywood on it to prevent that from happening. Preventing the cripple wall from collapsing is actually pretty simple. Just as we saw, you need to put plywood on it. So as you can see here in this house here, we have plywood on this end, and we put plywood over here. And notice we don't have to put plywood along the entire cripple wall. The engineering calculations behind FEMA P1100s tell us exactly how much plywood we need, and we'll go into that in another video. Now that we have braced the cripple wall with plywood on each end of the cripple wall, when the earthquake force moves underneath the house will try to slide off the foundation. And as the earthquake continues, it'll slide more and more until it falls off. Now, the only way to fix that is to bolt the cripple wall to the foundation. Bolting the house to the foundation is one of the easiest parts of any seismic retrofit. So this is the mud sill right here in pink. And that needs to be bolted directly to the foundation because that's the base of our cripple wall. So we'll come down here and look again. This is the base of the cripple wall. This is the mud sill. Here is the foundation. And when earthquake forces come this way and push on the base of the cripple wall, the mud sill, this is moving right here a couple of inches, so we don't want that to happen. If it moves too far, the house can fall off the foundation. So all we need to do is put in some bolts, connect the mud sill to the foundation, and we are all set. Now that we've braced the cripple wall with plywood and bolted the cripple wall to the foundation, there's one more thing we need to do. We need to make sure that the house stays attached to the top of the cripple wall, otherwise it'll slide off. So let me show you how that works. So here you can see the braced and bolted cripple wall sitting on the house. As the earthquake force comes again and pushes underneath the house as the ground moves, you can see how the house is starting to slide on top of the cripple wall. As it continues to slide underneath the house moves even more. As you can see on the right, it can fall off completely. So what we use is pieces of steel, also called connectors, which you'll see photographs of in a minute. The floor connectors are the last part of our cripple wall retrofit, and let me show you how they work. So this is the floor that you walk on. And then this is the floor framing that supports the floor you walk on. And then this sits on top of the cripple wall. And then this right here is the cripple wall itself. Now, an earthquake comes, we can't have this floor framing slide on top of the cripple wall. Naturally, we'll get damaged like we saw before. So here you can see what happens. Earthquake forces come here, and it slid a little bit. It slid, I don't know, 8 inches or so. We can't have that happen. So what we do is we install these right here called shear transfer ties or floor connectors. And that way, when the earthquake force comes this way, that force goes into the top of the cripple wall, and because the cripple wall is braced with plywood and it is bolted to the foundation, it can't move. Here you see 2 floor connectors. This right here is the top of the cripple wall. Now this floor connector here is called a type E connector in the FEMA P1100. And the way this works is this nail and then this nail and then this nail, they nail into this board right here. And there's some other boards, nails that come down this way. And when they come down this way, they attach to the top of the cripple wall. And that way, when the floor tries to move, it goes into this type E connector, and then that goes into the top of the cripple wall, which is what we want to have happen. Now this works exactly the same way. This is a different part of the floor here. When it tries to move, it goes into this type F connector and into the top of the cripple wall. And now that we've got our cripple wall, you know, if they were covered with plywood and then it was bolted at the bottom, we would then have a complete what's called a shear wall. A shear wall is something that resists earthquakes. It's made out of bolts, it's made out of floor connectors, and it's made out of plywood. Let's review everything we've learned up to now. Here is the mud sill at the base of our cripple wall. Earthquake force comes and tries to push the mud sill off the foundation, and then here we have the bolts to stop that from happening. Now over here we have the full cripple wall. Right here, there's the floor you walk on. And then here's the earthquake force trying to tip the cripple wall over. And then what we've done is we put some plywood on it to prevent that from happening. And finally here we have the floor that we walk on. This is the floor framing. Earthquake force is pushing this way, trying to slide the floor framing off the top of the cripple wall. And then we put in these shear transfer ties, also known as floor connectors. So now we've done everything we need to do to create a shear wall out of our cripple wall, and let's review it one more time. So again, this is the cripple wall. We can't have that collapse, otherwise the house will go with it. And here is our unreinforced cripple wall. So we see right here along the wall itself, it can collapse unless we put plywood on it, and then we come over here and then we see the plywood to keep the cripple wall from collapsing. Now this mud sill right here, we can't have that sliding on top of the foundation, because if it does, the cripple wall will go with it and it'll slide off the foundation. So what we've done over here is we put in the bolts. So we have a bolt here, we have a bolt here, and then there's also some bolts behind the plywood. Now the next thing we have to worry about is the floor can come sliding off the top of the cripple wall. So earthquake forces come this way, slides off the top of the cripple wall, and that's another failure point. And so what we do is we put the steel end right here so that when earthquake forces come this way, they're restrained by these pieces of steel called shear transfer ties or floor connectors. So that's pretty much all you need to do to convert a cripple wall into an earthquake resisting shear wall. Even though we've put in plywood, we put in shear transfer ties or floor connectors, and we've also put in the bolts, there's something else that can cause our shear wall to be damaged. So when you see the earthquake forces coming in from the left here, the shear wall is going to want to overturn, and this is it. It's trying to flip over like that. Very understandable that that would happen. So something needs to be done to prevent this from happening, because you can see down here below, it's starting to pull the plywood up off of the bolts. So this is the kind of damage I'm talking about. As you can see, the plywood has torn away from the bolted mud sill, which is severe damage. So right now I'm going to show you the hardware that is used to resist overturning. This right here is called a hold down. The other name for it found in P1100 is a tie down. Now what happens is this is a piece of steel and it's right here and it's bolted to this end of the shear wall. So this right here are two 2x4s that come this way. So this piece of steel is bolted to that. And so what happens when the earthquake force tries to turn this way, it pulls up on these 2x4s. Then those 2x4s pull up on the tie down. And there's the bolt right here, and it's very, very deep, 12 inches deep into the concrete. And it's glued to the concrete with very, very strong epoxy. And when it pulls up on the concrete. And because the concrete is so strong, it keeps the shear wall from overturning. That's why the tie downs are so important. Here you see an actual tie down. This is the tie down. This piece of metal right here is connected to the framing right here. And then we have a bolt, which is glued with epoxy down into the foundation right here. So the way this whole assembly works is a earthquake force tries to overturn the shear wall. That upward motion goes here into the framing. Then that upward motion tries to pull up on the hold down, and then the hold down is attached to the foundation through this all thread right here, which epoxied into the foundation so that when the hold down pulls up, it pulls up on this threaded rod, that pulls up on the concrete, and the strength of the concrete keeps the shear wall from overturning. Here are some foundation connectors found in FEMA P1100, and they're used to attach the mud sill to the foundation. So this is the type A connector, and right here is the mud sill, and it's attached to the concrete with this, connector right here. So there's bolts that go into the mud sill, and then there's the bolts that go into the concrete so that the two are attached. Now right here we have the type B connector, which is the exact same thing. This is the mud sill. Here's some bolts that go into the side of the mud sill, and then we have bolts that go into the side of the concrete. And right here we have the type C connector, which does exactly the same thing, except this one is unusual because it has this fold over here. So it comes here, and then it folds over the top of the mud sill, and there's nails that come down this way to connect it to the mud sill, and then it's also bolted here, here, and here. So we're going to be seeing these type A and type B and type C connectors later on in this series on FEMA P1100.